Okay, let's unpack this. Welcome to the deep dive. We've got quite a stack of material you've shared with us this industry briefing on semiconductors, first week of June 2025, Semiconductor Pulse, week 23, right? Plus some related news stuff.
That's right.
So our mission today is really to dive into this stack, pull out the crucial bits, and help you get a really clear picture of what's actually driving this industry right now.
And it's a fascinating sector, isn't it? I mean, it moves so fast. It's where the absolute cutting-edge science meets, well, massive global investment, and it's constantly shaped by economics and, yeah, increasingly geopolitics.
Definitely.
These sources you've given us, they really offer a great snapshot of all that complexity, touches on everything from the factory floor right up to international trade.
Absolutely. It's a lot for just 1 week's news, but yeah, that's semiconductors for you. So let's just jump right in. The absolute frontier, what's happening at the foundries, where the most advanced chips actually get made.
Okay. Well, what really stands out, I think, is the progress at TSMC. They're the leading contract manufacturer. And a key detail from the briefing is this reported milestone. They've hit over 90% yield on their bleeding edge 2-nanometer process.
Over 90% on 2 millimeters. That sounds incredibly high for something so new.
Yeah.
Does it say what kind of products that's for?
Yeah, it does specify. It says this high yield is particularly for memory products, which is, well, it's a pretty significant step for the nanosheet gate all around the GAA tech they're using there.
Right, GA.
And getting high yields early is just critical because, as the sources also really highlight, the cost is, well, it's astronomical.
Okay, tell me about that cost. I did see some eye-watering numbers in the material.
You definitely did. The reported cost, around $30,000 for a single 2-nanometer wafer.
30,000.
Yeah. And the briefing really emphasizes what a huge jump that is, like a significant 66% increase compared to their 3-nanometer wafers.
Wow.
And some projections, they even suggest costs could climb further, maybe reaching $45,000 down the line.
$45,000 for one wafer. That really puts it in perspective, doesn't it? Who can even afford to play at that bleeding edge? It's a massive barrier.
Oh, absolutely. It means staying competitive right at the front requires just immense capital. It limits the players, shapes the whole economic structure of the industry.
Yeah.
And TSMC, they're not just pushing the tech limits, they're expanding physically too. The material mentions plans for 9 new sites in 2025 alone.
9 new sites. That's pretty aggressive. I noticed Fab 21 Phase 3 in Arizona was specifically called out. Does that tie into like a broader strategy they mentioned?
It does, yeah. There's a strategic goal noted getting 30% of their sub-2-nanometer production eventually located in the U.S.
Okay.
So that really highlights this drive for geographic diversification, probably influenced by, demand from the big U.S. tech companies, but also these broader geopolitical thoughts about supply chain resilience.
So it's not just what tech, but where it's made.
Yeah.
Makes sense. And TSMC isn't the only one investing big in the U.S. based on these sources.
Correct. GlobalFoundries is also making a substantial commitment. They're reporting a $16 billion investment in their U.S. fabs.
$16 billion.
Yeah, and the breakdown mentioned is over $13 billion for expansions in New York and Vermont, plus a notable $3 billion specifically for R&D in advanced packaging and silicon photonics.
Packaging and silicon photonics. Those are definitely key areas for performance, especially connecting chips together. Okay, so bringing Samsung into this, what's their reported focus over in Korea right now?
Well, the sources indicate Samsung's strategy involves reportedly tightening DRAM production in Hwasong.
Tightening production.
Yeah, while at the same time focusing on improving yields for their 6th gen. That's the 1C DRAM. And this adjustment in, their core DRAM output, it suggested this could potentially influence the HBM market high bandwidth memory, because standard DRAM is, the foundation for HBM.
Right. So, okay, we just step back for a second. All this activity, the high yields and crazy costs at 2-nanometers, these huge investments by TSMC and GloFo in places like the U.S., Samsung's DRAM adjustments, what does it all tell us about the state of advanced chip manufacturing?
I think it paints a really clear picture. It's a global race, basically, defined by escalating costs and these really strategic regional pushes. The technical hurdles, getting those high yields on new nodes like 2-nanometers, immense.
Yeah.
And the money needed to build the capacity, buy the equipment, is just astronomical. So the moves by TSMC and GlobalFoundries, they reflect this calculated effort, right? Build out capacity in key regions, driven by market demand, sure, but probably also nudged by government incentives, the desire for more resilient supply chains.
Makes sense. has.
And Samsung's actions show how even the big established players are making these tactical production decisions in their core business, maybe anticipating shifts or optimizing for related high-growth spots like HBM. It's really a high-stakes game played out globally, where capacity and location are just as vital as the nanometer number itself.
That totally tracks. It's the whole ecosystem, tech, infrastructure, economics. Okay, speaking of HBM and memory, let's dive into those market dynamics presented in the sources.
Right. So the material highlights SK Hynix's continued strong position, particularly in AI memory. They reportedly showcased their latest HBM4 tech at the TSMC Tech Symposium. That's a prime spot to signal your capabilities.
And they seem to be leading the overall DRAM market, too. At least according to the Q1 numbers. The sources report SK Hynix took the #1 spot in Q1 2025 DRAM share with 36%, just slightly ahead of Samsung's reported 34%.
Yeah, even a 2-point lead in this market, it signals really intense competition. But it's interesting because the sources also paint a slightly counterintuitive picture for the overall DRAM market in Q1.
Right, I saw that. The total DRAM market reportedly dropped 5.5% in Q1, down to what, $27.01 billion. And the reasons cited were things like contract price decreases and maybe weaker than expected HBM shipments in that specific quarter.
Exactly. And that kind of raises a question, doesn't it? How can you have this booming AI demand driving HBM, but the overall DRAM market dips a bit?
Yeah.
The sources suggest it reflects this interplay of factors. Overall market trends can be swayed by inventory cycles, demand in segments outside the absolute AI cutting edge.
Right, like consumer electronics or standard servers.
Precisely. And also how quickly new HBM generations actually ramp into mass production. Contract price drops can happen even with strong long-term demand, maybe due to short-term inventory adjustments or specific customer deals.
Okay.
And the HBM market's growth, while explosive overall, doesn't mean every single quarter sees a jump in shipments. There can be lumpiness as big orders get fulfilled.
Right.
So, yeah, these numbers show the incredible focus on HBM, but within a broader, more cyclical memory market.
Got it. It's a market with layers, definitely. Now, none of this advanced manufacturing, none of these powerful chips, none of it happens without incredible equipment. Let's talk lithography, the key tech for printing patterns on wafers.
Exactly. And the frontier there is EUV extreme ultraviolet lithography, especially the next-gen stuff, High-NA EUV from ASML. But the sources note a reportedly slow uptake of these High-NA tools.
Slow uptake. That's surprising. Given how critical they are supposed to be for the really advanced nodes, what's the reason cited?
Cost. That's the main factor highlighted. The big manufacturers, TSMC, Samsung, they're reportedly being cautious because of the incredibly high price tag on these machines. And the shipment projections reflect that. Only 3 units expected to ship in 2026, which is actually reported as a decrease from the 5 units projected for 2025.
Because that cost barrier we saw with the wafers extends right to the machines making them.
Okay.
But while adoption of the absolute cutting edge might be slow for some, other players are reportedly pushing really hard to develop their own capabilities in litho.
Right. This is where the sources detail China's significant domestic push. They are reportedly backing efforts to develop their own EUV lithography systems, with a substantial investment, 37 billion mentioned.
37 billion euros. Wow. And the timeline reported.
Pretty ambitious. Trial production expected Q3 this year, 2025. With mass manufacturing targeted for 2026.
Yeah, that would be a massive development if they hit that timeline.
Yeah.
What's the strategic importance here, according to the material? Why the big push?
Well, control over advanced lithography is seen as, fundamental to national tech self-sufficiency. The sources frame this huge investment as a strategic effort, reduce reliance on external suppliers like ASML, build up indigenous capabilities.
Right.
The technical and financial challenge is obviously immense, but the reported motivation is clear. Control a critical choke point in chip manufacturing, and potentially alter the global competitive landscape if they're successful.
It definitely adds another complex layer to that global tech competition story. Okay, shifting gears again slightly, let's look at where a lot of this demand for advanced chips is coming from. AI, and the innovative ways people are designing for it, like using chiplets.
Yeah, the sources give some concrete examples of companies really benefiting from the AI surge, like Broadcom. Their financials related to AI chips are detailed.
And they are impressive. They reported $4.4 billion in Q2 AI chip sales. That's a huge jump, 46% year over year. And they're forecasting even higher for Q3, looking at $5.1 billion.
And that growth, it's reportedly being driven by the big guys Google, Meta, ByteDance are mentioned, really shows how the hyperscalers and large tech firms are just fueling this specific segment's rapid expansion.
Yeah, the demand is clearly there. And beyond just selling individual AI chips, the sources also talk about innovation in chip design, using approaches like chiplets.
Yes, Alphaway Semi gets highlighted here. They reportedly hit a key milestone, taping out their UCI IP on TSMC's 2-millimeter process.
UCI on 2-millimeter.
Yeah, and the technical detail is significant, hitting 36 gigabits per second die-to-die bandwidth.
And this works with advanced packaging like CoWoS, right?
Yeah.
So why are these details UCIe, CoWoS, 2-millimeters, and why is that important?
Exactly. So UCI is basically a standard interface allowing different little chiplets, to talk to each other really fast.
Yeah.
And CoWoS chip-on-wafer-on-substrate is that advanced packaging technique that puts these chiplets super close together. Achieving high bandwidth using a standard like UCIe on a leading-edge process like 2 nanometers, combined with advanced packaging, it's crucial.
Why crucial?
Because it lets designers build these incredibly complex, powerful processors for AI and high-performance computing by mixing and matching specialized chiplets in one package. It helps overcome the physical and economic limits of trying to build one single giant chip. It's really a key enabler for keeping performance scaling going in the AI era.
Gotcha. So chiplets and advanced packaging really becoming foundational for future HPC. Now, as we've kind of touched on throughout, none of this operates in a vacuum. Let's talk about the geopolitical and regulatory landscape described in the sources.
Right. The briefing reports on new export controls from Washington targeting China. And these controls specifically mention things like EDA software.
Electronic design automation, the software to design chips.
Exactly. That plus certain chemicals and tools used in chip manufacturing and design.
And the stated aim, according to the material, is basically to slow down China's domestic chip development progress.
That is the objective reportedly stated behind these controls, yes. The sources also mention potential impacts inside China, noting that firms like Xiaomi could reportedly face challenges, particularly getting access to critical EDA tools for future chip designs.
So it's not just the physical gear, but the essential design software, too. Interesting. What about reported countermoves or strategic plays from China's side?
Well, the sources report on China moving to expedite rare earth export licenses, specifically for EU companies.
Rare earths to the EU.
Yeah, and this is framed as a reported strategic maneuver, possibly aimed at, stabilizing certain trade routes or maybe leveraging economic ties amidst these broader tech tensions that are outlined in the material.
This complex interplay, regulations, reported countermoves, it seems to directly impact the industry day to day. How do these geopolitical factors, as presented in the sources, really influence things for semiconductor companies?
Well, they create a pretty challenging and frankly uncertain operating environment. Regulations on tech exports, market access, they directly influence supply chain decisions, right? Where companies invest, how they plan globally.
Yeah.
And counter moves, like with critical materials, they just highlight how interdependent the global supply chain really is and the potential for strategic leverage. The sources describe these dynamics as basically forcing companies to think really hard about resilience, about regionalizing capacity, and just navigating increasingly complex international relations, all while trying to innovate at a breakneck speed. It's really about reporting how these government actions and reported strategies, just as presented in the sources, add these layers of complexity to an already complex industry.
It's definitely a reminder, isn't it? This industry isn't just engineers and fabs. It's deeply tangled up with global politics and economics. Okay, let's try and wrap up by looking at some overall market trends and projections mentioned in the sources.
Okay, there was a positive signal noted in the material. Global chip sales reportedly saw an increase back in April. The sources indicate a 2.5% rise, reaching $57 billion.
And that's significant because it's the first reported monthly increase in 2025, right?
Yeah.
What were the drivers cited for that growth?
Yeah, highlighted as the first monthly increase this year. And the primary drivers cited in the sources for that April bump, AI and data centers.
No surprise there. That lines up perfectly with the growth we saw from companies like Broadcom earlier. Are there any long-term projections in the material, something that gives us a sense of where things are headed, especially for key technologies?
Yes, there is. A projection for the EUV market size. It's expected to reach $28.5 billion by 2035, with a reported compound annual growth rate CAGR of 9.2% over that period.
Okay, 9.2% CAGR for EUV.
Yeah, and that figure really reinforces the continued critical importance of advanced lithography. It anticipates sustained investment despite, the current high costs of those High-NA tools we talked about.
So Taking these market trends and outlooks together, what do they suggest about the overall health and future direction of the sector, based purely on the sources you provided?
Well, these numbers suggest that maybe after a flat patch or slight dip early in the year, the market might be starting to recover, with AI and data centers clearly being the key engines driving that growth.
Right.
And that long-term projection for EUV investment. It just underscores that the fundamental push for smaller, more powerful chips isn't slowing down, even if the path forward means navigating these immense costs and technical hurdles. It indicates that the investments we discussed in foundries, advanced packaging, and yes, despite slow adoption, eventually in cutting-edge equipment, they're all contributing to an anticipated long-term growth trajectory for the industry, heavily skewed towards high-performance computing and AI applications.
It really is incredible to see how all these pieces fit together. The raw technical yields, the multi-billion-dollar investments, the global political chess, market fluctuations. It's just an incredibly complex industry. So just to quickly recap this deep dive into the sources you shared, we covered the monumental costs and tech achievements at the 2-nanometer frontier.
Right, the yields and the wafer costs.
Exactly. The strategic race for manufacturing capacity playing out across continents, those dynamic and sometimes, well, contradictory trends in the memory market, with AI really driving that HBM segment.
Even as the overall market saw a dip.
Yeah, the high-stakes competition and ambition in lithography development, both adoption and domestic efforts. The clear impact of AI demand, boosting specific companies and enabling tech like chiplets. And of course, the significant hand that geopolitical forces are playing in shaping the entire landscape.
Exactly. And if you connect all those dots, particularly the immense capital needed for next-gen manufacturing, potentially $45,000 per wafer, and you couple that with this global push for regional self-sufficiency in critical tech, it raises a really powerful question, I think, for you to consider.
Okay.
How will this fundamental tension between the necessity of a global scale on one hand and this increasing desire for local control on the other, how will that ultimately shape the semiconductor industry structure in the decades to come? Are we going to see true fragmentation into distinct tech ecosystems? Or will the sheer cost and complexity necessitate new forms of collaboration, maybe even between unlikely partners? What does that mean for the speed of innovation and ultimately the cost and accessibility of advanced technology for everyone?
That's a fantastic thought to leave everyone with. The battle for the future of semiconductors is definitely far from over, and its structure really does seem to hang in the balance. Thank you so much for providing these sources and letting us take this deep dive with you today. It's a truly fascinating and, frankly, critical area to understand. Keep pulling on these threads and exploring.